This video goes through the solution for Algebra 3, page 460, question 13. So at the start of this question, we're given two statements, and we're asked to give an example to show that both of these are true. So essentially what they're asking us to do is to select a value for a and b and n, and then check and see if we actually get the conclusions that we expect to get based on the statements. I'm going to number these statements number 1 and number 2 for clarity. And I'm going to check the statements by letting a equal to 3 and b equal to 2. And since in statement 1 I want n to be greater than 0, I'll just pick 2 for n. Now I'm going to check and see if a to the power of n is greater than b to the power of n. Well, a to the power of n is 3 to the power of 2, and that gives me 9. And b to the power of n is 2 to the power of 2, and that gives me 4. And I can state with confidence that 9 is bigger than 4. So on that basis, I'll conclude that a to the n is bigger than b to the n. Okay, statement 1 done. On to statement 2. So I'm going to choose n equals minus 2. It doesn't matter what n value you take. I'm just trying to take a fairly convenient value. So I'm now going to apply this to my a and b and see what happens. So a to the power of minus 2 is 3 to the power of minus 2, which you can write as 1 over 3 squared if you like, which is 1 over 9. And b to the power of n is 2 to the power of minus 2, which can be written as 1 over 2 squared, which is a quarter. Now, obviously, you can use your calculator to go straight from 3 to the power of minus 2 to 1 over 9 and 2 to the power of minus 2 to 1 quarter. I'm just putting this little bit in the middle in just to remind ourselves of our rules of indices as we go. And I can see that 1/9 is definitely smaller than 1 quarter. So in this case, a to the n is less than b to the n. Notice how in both cases here, I didn't fill in my 3 squared and 2 squared, for example, straight into this inequality statement. I evaluated both pieces of the statement first of all, checked the numbers, and then concluded with the statement as it had been given in the original question. So I'm only making the statement when I'm sure that it's correct. So in part 1 of the question now, they want us to take the situation where a is less than b is less than 0, and n is a positive number, but it's odd. And I want to see then, can I make a statement about a to the n and b to the n? Will a to the n be bigger, or will it be less than b to the n? Again, it's a good plan to take values for your a and your b and your n to see what happens. So I'm going to choose a is minus 3, b is minus 2, and n equals to 3. I'll write a to the n as minus 3 to the 3. Notice the bracket that I'm putting around that minus 3. And the result I get is minus 27. b to the n is minus 2 to the 3, which is minus 8. I can state that minus 27 is less than minus 8. And so in this set of circumstances, a to the n is less than b to the n. Notice in this case the effect of an odd power on my base number. So I've got a negative number to an odd power, I get a negative result. Next we have a less than b less than 0, where n is a positive even number. So I've chosen minus 3, minus 2, and 2 of my values for a, b, and n, and now we'll submit and see what happens. So a to the n is minus 3 squared, which is 9. And again, just watch out to put in that bracket, because if you don't and you use the calculator to evaluate, it's going to give you a negative result. b to the n is minus 2 squared, which is 4. We can see that 9 is greater than 4, so a to the n is greater than b to the n. So in part 3, a is less than b is less than 0, and n is a negative odd number. So I'm going to let a be minus 3, b be minus 2, and n be minus 3. If you've chosen different values for this, that's not a problem. You should still get the same results at the end in terms of the inequality. So first of all, we have a to the n, which is minus 3 to the power of minus 3. Now let's just think about the lessons we've learned from earlier calculations here. We know, for example, that a negative number to an odd power gives us a negative result. So I'm expecting a negative result here. And also I note that I've got a negative power. So that means that I'm going to end up with a fraction answer. I can, of course, just stick my numbers straight into the calculator without thinking too much about it, but it's always a good plan to try and observe the patterns that are recurring. So in this case, a to the n is minus 1 over 27. b to the n is minus 2 to the power of minus 3. So odd power, my value will stay negative, and negative power is going to end up as a fraction. Now, minus 1/8 is further down in the negative direction than minus 1 over 27 is. So b to the n is smaller. That means a to the n is bigger. So our conclusion in this case is that a to the n is greater than b to the n. And finally, we have the statement a less than b less than 0. N is an even number that is less than 0. So I'm going to choose values of -3, -2, and -2. So for a to the n, I'm going to get a result of 1 over 9. I get a positive result there because I've got an even power, and I get a fraction because of that minus in front of the 2. So b to the n is -2 to the power of -2, which is 1/4. So let's have a think about 1/9 and 1/4. 1/9 is less than 1/4, so a to the n is less than b to the n.